I want to talk about how to find the domain of a composite function. So I want to do the composite function, f of g of x. So when you're trying to find the domain of a composite function, you always start with the innermost function, because whatever is going to be excluded from the domain of g of x is certainly not going to work in f of x. I mean, if I get a number in g of x that doesn't exist, then I certainly can't find f of a number that doesn't exist. So I'm going to start with g of x here, and I know that one of my domain restrictions is that I cannot have a 0 in a denominator. So I set x minus 3 equal to 0, and I find x equals 3, so I know that x cannot be equal to 3. So my domain restriction is x cannot be equal to 3, or if I wanted to write my domain in interval notation, I would go negative infinity, comma 3, parentheses, union, 3, comma, infinity. So that is the domain of g of x. Now the next step is I want to take a look at f of x. So I look at f of x, and I say, well, for f of x, I can see that x cannot be equal to 1. Because if x is equal to 1, I'm going to have some problems. It's going to explode. But the key here is that I'm not really that concerned about the domain of f of x. I am concerned about the domain of the composite f of g of x. So what I'm saying right now, and you might want to replay this a couple of times and think about it, is I have to make sure that g of x is not equal to 1. G of x cannot be equal to 1, because if g of x is equal to 1, then my f of g of x is not going to work. So what I do, if I can't have g of x equal to 1, well, what would make g of x equal to 1? I will set g of x. I'm going to go g of x is equal to 1 over x minus 3. And I'm going to set that equal to 1 so I can find out what I can't have for g of x. X minus 3 equals 1. I'll multiply both sides by x minus 3. That cancels out, and I have 1 equals x minus 3. I add 3 to both sides, and I get x is equal to 4. So what this is telling me is that x cannot be equal to 4. If x is equal to 4, then g of x is going to be equal to 1, and then f of g of x isn't going to work. Let's just prove that. I hope this writing isn't getting you too crazy here. But if I make, let's see here. Okay. So g of x is 1 over x minus 3. So let's draw a line right here. G of x is equal to 1 over x minus 3. G of 4 is equal to 1 over 4 minus 3, which is equal to 1. Well, that causes me a problem, because when x is equal to 4, g of x is equal to 1, and f of g of x would be f of 1, and that would make this not happen. That would make that undefined. Now, I hope that's clear. But the other thing I want to point out is that if I look at my f of x all by itself, I can see that f of x cannot be equal to 1. But f of g of x is okay for 1, because I'm looking at g of x as my argument for f of x. Let's take a look. So I have g of x is equal to 1 over 3. Let's go to the bottom here. Let's just rewrite these functions here. Sorry for taking your time on this, but let's do it. Okay, so I'm going to go, I'll copy this. Let's go down here. I'll extend the page. And I'll paste it. Okay. Stop my way, please stop giving me difficulty. Okay. So I know that with just f of x, I'm looking for f of g of x as my composite. For just f of x, x cannot be equal to 1. Well, let's try it in our composite. G of 1 is equal to 1 over 1 minus 3, which is equal to negative 1/2. Well, what about f of g of 1? F of g of 1 is the same thing as f of negative 1/2, because g of 1 is equal to negative 1/2. And I can plug that in. So I'm going to go f of negative 1/2 is equal to 1 over negative 1/2 minus 1, which is equal to 1 over negative 3/2, which is equal to negative 2/3. There's no problem with negative 2/3. So if x is equal to 1, it doesn't impact my composite function. I'm finding the composite function. So even though 1 doesn't work for f of x alone, I'm not concerned with f of x alone. I'm concerned with the composite function. Composite function, look at the inside one first, look at the outside one, well, look at the outside one second, and make sure that you set the inside one equal to the restrictions of the outside one, and then that's what's not allowed in your domain. So in this case here, just to sum this up, the two numbers that are excluded from our domain, x cannot be equal to 3, and x cannot be equal to 4. And again, if I wanted to write it in integral notation, you don't have to, but it would be negative infinity, comma 3, union 3, comma 4, union 4, comma infinity. So I've done everything except for 3 and 4.